go through different threat scenarios. If there's an authentication attack, right? What if malware is introduced? Is there any intellectual property that might be stolen?
Welcome, listeners, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and guest of our show today. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Paul Piotrowski. He is a Principal OT Cybersecurity Engineer with global responsibility at Shell. And he's going to be talking to us about risk assessments. I mean, risk assessments are a first step in a lot of security programs. You know, they're a recurring task, you know, once the program's established. Paul walks us through a deep dive into the IEC 62443-3-2. 3-2 is the standard for risk assessments. You know, mostly we talk about 3-3, which is the standard for, you know, how to prevent attacks. So he's going to take us through risk assessments, best practices, some firsthand experience, and some examples.
Then without further ado, here's your conversation with Paul.
Hello, Paul, and welcome to the podcast. Before we get started, could you say a few words about yourself, about your background, and about the good work that you're doing at Shell?
Yeah, thank you, Andrew. Thank you for the invite. Glad to be here to talk about my experiences doing cybersecurity risk assessments at Shell. So yes, I've been in this industry for a long time now, 20 plus years at Shell. Started my career early on in the operations kind of discipline, running firewalls and networking, and then eventually moved into cybersecurity. And the last 10 years, I have spent my time as a global OT security role, working globally for our joint ventures and non-operated joint ventures, and also involved in SANS as well, helped create the ICS 410 class a decade ago. I also teach that class, work with the SANS organization on numerous different initiatives around the world.
Our topic today is cybersecurity risk assessments, and you know the needs, the drivers that you see in that space. Can you start at the top? Talk about risk assessments.
Yeah, so the last few years there's been a lot of focus on cybersecurity risk assessments, and there's many drivers from our vantage point on why an organization would do a cybersecurity risk assessment. So I'll kind of iterate through. You know, the first one I see is regulatory requirements. So certain industries like the functional safety IEC 61511 actually requires it in their standard. So the functional safety discipline is driving a lot of the work that we're seeing internally within our organization. But more widely, there's also an appetite to understand your operational risk. We all know cybersecurity and ICS is difficult. You can't patch everything, so you really have to hone in on the high risk items in your environment. And so doing a cybersecurity risk assessment allows you to do that and allows you to apply your finite resources to where it matters. We also see risk assessments being used for internal and external assurance activities. So, every organization has an audit arm, and we use those as well to provide that necessary assurance across the organizational lines. And in unique situations, we use cybersecurity risk assessments also to justify and refute investment decisions. So we've had a few cases where we do a cybersecurity risk assessment, and it actually goes against what the business capital investment plans are, which is a unique kind of observation that we found in doing some risk assessments.
You mentioned a situation where a risk assessment contradicted an investment initiative. Can you give us just a little more insight into this? Was this a security investment that the risk assessment said was not necessary? Was this building a facility for processing hydrocarbons that the design proved too dangerous cyber-wise? What can you give us just a little more insight into what?
Yeah, absolutely. So it was more of an obsolescence issue, Andrew. And so the business decided that they wanted to spend X amount to update some obsolescent field devices for a SCADA application. And once we did the cybersecurity risk assessment, we determined that we had lots of surplus equipment, and our philosophy around sparing was very sound, and the overall cybersecurity and operational risks were very low. And so we actually went back to the business and presented that, and we're kind of working through that. But that was an interesting kind of observation where the cybersecurity risk assessment activity determined that it was a low risk, that we were mitigating the risks, right, of hardware failure, etc. And we deemed that it wasn't in the best interest of the organization to do a large capital investment, and the finite capital could be deployed somewhere else that is more value add to the organization.
I would say that's a relatively unique thing to say on this podcast. Andrew, in past episodes, whenever it comes up, I've always heard you harp on the issue of shaking loose budget, that there's always too little money, and how do you convince people of the necessity and the specifics of industrial security problems. In this case, he's saying, they had a case where they didn't need the money, so you could go use it elsewhere.
That's true, but what was it? Last episode, a couple episodes ago, Matthew Malone was on from Yokogawa. He was talking about shaking money loose, and he was saying, if you remember, he's working in the oil and gas industry, but he's working with the small to medium-sized organizations. He said, unlike the majors and the super majors, it's really hard to shake money loose in these sort of underfunded organizations. Shell is not a small organization. So yeah, they are one of the leaders in the space. They've been doing cybersecurity since the beginning. And so, this kind of example is kind of what we expect from the leaders in the field, as opposed to the small outfits that are scraping by on the border of profitability. You folks, you personally use the IEC 62443 standards routinely in your risk assessments, especially the, the 3-2 standard, which is about risk assessments. We've never really had somebody walk us through the standard. Can you talk about what is 3-2 and sort of what's in there? What do you use?
Yeah, so a lot of people think that IEC, right, 62443 is just kind of one set or one document, but it's actually a suite of documents. And the 3-2 speaks to security risk assessments for system designs. And so we decided to use that standard because, as you could understand, we're a big organization, and the engineering discipline really gravitates to the IEC standards, right? And we felt that we could scale it globally, right? The use of it, and as well, it's more well understood than other risk assessment kind of methodologies in the engineering discipline. And so there's numerous cases where, our internal team, we're not big enough to do all these cybersecurity risk assessments across the globe. And so you can easily go to a vendor, a third party, and ask them to follow the IEC 6243 methodology, and usually you'll get good results, right? Because it's well understood, and you have kind of the same basis for discussion that allows you to, execute these risk assessments.
That makes sense. I mean, it makes sense that you use the 62443. But you haven't really told us about what the process looks like. Can you dig into 62443-3-2 for us? You show up on site. What happens? What sort of big picture? What does one of these assessments look like?
Yeah, that's a good question. Each assessment, I would say, is a little bit unique, and you have to kind of customize it, right? So usually in our organization, a request would come in from a line of business or a particular asset, where they would say, we need some assistance doing a cybersecurity risk assessment. We don't have the skill set on site to facilitate it, and they would call our organization or my division, right, to help facilitate that. So we would have a kickoff meeting, right? During COVID, it was obviously virtual, but now we're going to sites more often. You would, sit down, and I usually like to have a kickoff meeting, and bring in all the necessary people that are going to be involved, and really frame the discussion of what we're trying to do, right? And what we're trying to do is identify the system under consideration. So what exactly are we assessing? Are we assessing a pipeline, SCADA network? Are we trying to cyber assess DCS system by a particular vendor? Is it a small manufacturing facility? Is it a Gulf of Mexico platform? You really have to hone down on where the scope ends, right? You have to kind of draw a circle of which system you're actually going to be looking at. That might include or might not include third-party connected systems, etc. Right? You have to draw the barrier, right, of what you're actually going to be looking at, and then you want to do some reviews, right, of previous audits or observations, right, that the site has. You need to look at network diagrams. You want to walk down the site to understand, how it's physically connected, whether it's serial connections, TCP, wireless connectivity, you name it, right? If there's any standalone hosts, you really need to get an asset inventory of what is in your system under consideration. Once you have a good understanding of, what you're going to be a cyber assessing, you break it down into logical or physical or functional kind of zones, right? So if you have a wireless deployment of field sensors, that might be, one particular zone. If you have transient assets like technical laptops, that might be another zone. If you have engineering workstations, controllers, etc. So you need to really break it down into different zones. Once you have that identified and you have the host names and IP addresses and VLANs and the technical details of these zones, you would sit down with people that are knowledgeable in those systems and have a discussion about the different threats and vulnerabilities that might exist for a particular zone. So I always use in my kind of initial kickoff meetings, everybody knows ransomware. We've seen pictures and lots of publications in the news around ransomware, and you have a discussion. What if this engineering workstation was encrypted with malware, right, or with a BitLocker or whatever it might be? Asking you for cryptocurrencies, right? What would be the impact, right, to the asset by this machine or this network going down? And then you would start talking about the likelihood of that occurring, the consequences of that, and then you start talking, how can we mitigate? And then you rank that, right? You have a RAM matrix that we'll talk about, risk assessment matrix for your organization. We'll talk more about that, later in this podcast. But once you start assessing the unmitigated risk and of that occurring, then you start talking about what controls do you have from an organizational standpoint that would mitigate that machine from being encrypted with ransomware. And then you have those discussions, how well are those controls being operated, et cetera, and then you hopefully can reduce the likelihood of that occurring, and then get validation that your controls that you have in your organization are effective or maybe not effective, and then you have to put in additional controls in place to mitigate the risk of ransomware encrypting a particular machine. And so some of the main two concepts that we use when we do this whole activity is talk about likelihood and consequences, right? So the likelihood, you have to determine whether it's going to be a certain likelihood of a particular scenario materializing, and then the actual consequences, right? What can happen, right, if that engineering workstation gets encrypted with ransomware, right? Is there a consequence to people, to assets, to community, to the environment, consequential business loss, right, of you rebuilding that machine, loss of production? All those questions have to be answered as part of the 62443 risk assessment methodology and process that you will execute in your organizations.
So, this sounds, you're going to drill down in a minute. This sounds like a lot of work. Can you tell me, how long does one of these engagements typically take? Are we talking months? Are we talking years? Are we talking days? What's the scale here?
Yeah, so it depends on the actual engagement, but let me give you some examples. For like a big capital project, let's say you're building a new plant or you're doing a big brownfield project, it's not uncommon for it to take quite a bit of time, 100 plus hours, right? Preparation is key, and getting and doing those workshops either in person or in a virtual environment, does take time. Let's not sugarcoat this. This is doing a proper cybersecurity risk assessment on a larger asset takes a long time. And so we've done risk assessments where we've identified 40 zones. I gave you a few examples of the engineering workstations or technical, transient laptops, etc., controllers. Those are some of the zones, but we've had bigger, larger cybersecurity risk assessments where it's 40 plus zones that we're assessing. And we had at the biggest one that I have facilitated included over 35 people globally, right? We had people dialing in from a Mac vendor, main automation contractor vendor in India, right, providing feedback and input into their DCS infrastructure, etc. So, and then obviously on the smaller side, I'm involved in a smaller cybersecurity risk assessment. It's still taking quite a bit of time, but we only have 6 people, right, in that particular risk assessment because those 6 people are very knowledgeable, on the process, on the asset, on all the connected systems, and they're able to make those final calls with regards to the consequences, right, of a particular event, threat scenario materializing. And we felt that we don't need additional people because the 6 people involved will suffice, right? But sometimes, we do have to call in some other members from other teams to get involved. So kind of words of wisdom is, don't involve the right amount of people. Don't invite people that don't need to be there, that are just listening in. You want people to be active contributors in the workshop or in the conference calls that you're facilitating.
Paraphrasing what I heard Paul say here, in my understanding, one of these assessments, typically takes a few weeks, some, I don't know, 3 weeks, 6 weeks at a large site. This is my understanding. It was interesting to me to contrast this with what we heard from Sarah Friedman. Sarah was talking about the CCE methodology, which is primarily a risk assessment methodology as well. I regard the CCE methodology as sort of the, what's the right word, the gold standard in the industry for risk, industrial risk assessment. She said that, a typical CCE engagement will take, 3 or 4 months, which is longer than I understand the longest that, the 3-2 takes here. And it's ironic that Sarah positioned the CCE methodology. I said, why was the methodology created? She said, because risk assessments were taking too long. Because she was talking about, military grade risk assessments taking, 1 to 2 years. And by the time the risk assessment is done, the world has changed so much that the results of the assessment are meaningless. And so, they shortened down that, heavy duty risk assessment to a mere 3 or 4 months. Yet here, 3-2 seems to be, what's the right word? This is what most of the industry uses. And, like I said, Idaho National Labs is trying to persuade people to go to the sort of the more thorough CCE sometime down the road that is taking rather longer.
Yeah, and it seems great in theory that we're implementing so much efficiency that a once 2-year process becomes 3 or 4 months, becomes 3 or 6 weeks. But what exactly is it that we are shortening? What shortcuts are we taking, or what are we making so much more efficient that we could make such a vast improvement?
I don't know if it's an improvement. I think it's a different approach. And I didn't ask Paul this question, but my understanding of the difference between 3-2 and CCE is what CCE calls system of systems analysis. And, an even more thorough mechanism. We had the gentleman on from Amanaza who does the attack trees. That's an even more thorough analysis of attacks. Systems of systems analysis is looking for mechanisms by which a sequence of events by which an industrial control system could be compromised. Think of it as a path through the system to result in compromise, an attack path. Attack trees sit down and enumerate all, or as close to mathematically possible, all of the attack paths. And we're talking as many as over 1 billion, with 10 to the ninth attack paths for a given site. What CCE tries to do is do that not algorithmically with technology. They try to do it sort of manually, but they go through the analysis and they try to find choke points. So they don't try to enumerate by hand all the billion attack paths. You can't do that. You need technology for that. That's why NASA has a market. But you can do it sort of qualitatively and look through and say, there's a choke point here. All of this kind of attack, there's only 3 ways to get into the system. You have to come through one of these choke points, and then they focus their defenses on the choke points in order to interrupt the largest number of attacks. Whereas what I understand 3-2 does is a little more qualitative. It looks at an asset like the engineering workstation and the ransomware scenario that Paul was talking about, and says, okay, how heavily defended is the asset? Have we got passwords and antivirus? Is how many layers of firewalls do we have out to the internet, the source of all evil? And they do a more qualitative assessment of how heavily defended is it, and the more heavily defended something is, and in a sense, the more sort of the less common the code base is, the harder, the more code you have to write to attack an asset, the more difficult it is to attack the asset, the less likely a qualitative score you get. So they do more of a qualitative analysis. CCE does, attack paths and choke points, whereas an attack tree will be comprehensive.
So then in what scenarios is 3-2 appropriate versus when is CCE necessary, or if need be, the military grade 1 to 2 year kind of assessment?
That's a good question, and that is something that's debated in the industry. Everyone that I ask believes that what they're doing is the right thing to do. But and I didn't ask Paul this question. Maybe I should have. So I don't want to put words in his mouth, but my guess is that the majors generally are always open to new ideas. I know these people. Some of them are evaluating CCE. They're sending their people to the training. They're trying to figure out where to use which methodology. I know that if you have an asset where the consequences of compromise are truly unacceptable. I don't know if you have a power plant or a refinery close to a population center. You might want to be even a little bit more cautious and, take on the attack tree tool in addition to the CCE. I don't know. This is not a space that I'm really familiar with, but I know that, factors that play into it are consequence, especially consequences for public safety, and just sort of understanding. I mean, the space continues to evolve. The threat environment continues to evolve. Owners and operators in the space, they're evaluating these tools. They basically everybody, in response to the worsening threat environment, everybody I talk to over time is becoming more and more thorough with everything they do. Everything from the smallest organizations who say, we got to get started, to the largest organizations who say, we got to take the next step. Where is the whole industry, different industries in that space? I can't say. We need to get an expert on who's, sort of more familiar with risk assessments in lots of different industries.
In the beginning of the industrial security revolution, engineers were told to use IT security principles. Protect the information, we were told. We knew this was a poor fit, but it was all we had. Today, the top security priority at industrial sites is safety. Don't kill anyone. Don't cause an environmental disaster. And the second priority is reliability. Do not shut down our factory or infrastructure. Today, safe and reliable operations use unhackable protections from cyber risks, not just cybersecurity. For a deeper look at the evolution of the revolution, we invite you to download Waterfall's report on the emerging consensus for industrial security engineering. You can access the report at the Waterfall website, waterfall-security.com/engineering-consensus, or just go to the resources menu and click on white papers and ebooks.
You've been using 62443-3-2, the risk assessment methodology, for some time. And, that document is a number of years old now. People learn by using the document. It eventually gets revised. Have you modified the methodology at all? Is there stuff that you see that, arguably needs to be changed in a future version of the document?
No, so we've tried not to change it too much, because the problem that we've encountered is if you change it, then you need to explain it, right, to our vendors and our partners that are doing these cybersecurity risk assessments. So we try not to change it as much as possible. Internally, we have changed the color coding that we use on the matrix, on the RAM matrix, because there was some confusion with the HSSC RAM matrix. And so we made those changes to differentiate between the two two matrices. And then we also added a separate column around consequential business loss, because our businesses wanted to understand what is the financial cost, and they wanted to see it, right, as a consequence if a particular unit or a production line, right, is off spec or is shut down due to a threat, etc. And so those are kind of the two major ones that we've made that actually helped us facilitate the cybersecurity risk assessments in a better fashion.
Now, you've mentioned these matrices a couple of times. Can you go a little deeper? What is this matrix? And you've talked about sort of network zones. I think you have a matrix per zone. How does this work?
Yeah, so we actually have one matrix that we refer back to when we do these cybersecurity risk assessments, and our matrix is a 5x5 kind of matrix, right? That goes into the likelihood, and so we have kind of 5 categories, right? Highly unlikely, and then unlikely, probable, likely, and certain, right? So getting back to my previous comments, with ransomware or malware infected via USB, a Windows machine, or whatever, we consider that as certain to happen, right? And so you have it's a combination of likelihood and then the consequences, right, on the other axis. And so the consequences that we look at, are from HSSC standpoint, right? Is there impact to the people? Is there impact to the physical asset? Is there impact to the community? Is there impact to the environment? And then is there any consequential business loss, right, of a particular unit or process going down? What is it? What's the cost associated with not being able to produce?
Okay, so you've mentioned the risk matrix. You've talked about zones. Are you talking about zones in the sense of 62443, network zones, which sort of everyone else calls network segments? Or, is a zone something else? And how do you apply the risk matrix to a zone? Walk us through dealing with a zone, please.
So from the system under consideration step, right, once we've identified what we want to assess, we break the ICS environment into different zones. Now, the zones could be a functional zone, it could be a network segment, network VLAN, right? It really depends on what the team thinks is appropriate. And so it could consist of one host or multiple hosts or multiple VLANs, etc. Right? So once you have a zone defined, right, it could be an engineering workstation or workstations. It can be a whole bunch of wireless devices. It can be calibration units, whatever it might be, switch infrastructure, right? Once you have a zone defined and you understand what the IP addresses are, what the physical devices look like, etc., right, you say, we're going to hone in on that particular zone, right? We're going to assess that zone from a consequence and a likelihood perspective and map it back to the risk assessment matrix that you as an organization have picked. Now, the RAM matrix can be a 3x3 matrix. It can be a 4x4. Ours is a 5x5 matrix that has different categories for likelihood. We use highly unlikely, unlikely, probable, likely, and certain. And then we have different consequences as well, right, from a severity impact perspective related to people, assets, community, environment, and consequential business loss. And so once you have a zone, you would sit down with your team, right, consisting of how many people are able to attend and who are knowledgeable on the system, and you go through different threat scenarios, right? What if malware is introduced? Is there any intellectual property that might be stolen from a particular zone, right? Those types of things, right? If there's an authentication attack on that particular zone, and then you go through the matrix, right? What is the consequence of that happening, of that materializing? And you first assess the unmitigated risk with no controls whatsoever applied, right? And then you have a consequence, and then you have a discussion about the likelihood, right? Is it a Windows machine? Is it a particular switch that has firmware on it, etc.? How exploitable is it, right? And then you essentially find a box, right? And you have a discussion, right, with the people and find where it needs to be on the RAM matrix. And then once you have the unmitigated consequence and the likelihood, then you start talking about what controls your organization has. Do you have antivirus installed on that Windows machine, right? How are you doing physical access controls to that machine? Do you have proper governance for that particular machine, right? And hopefully with those controls that you understand, then and are operating effectively, the likelihood of that threat scenario materializing is going to be significantly less. The consequence will never change, right? You can't change the consequence from the unmitigated consequence, but you can reduce the likelihood of that threat materializing by doing patching, by having antivirus installed, by having it physically secure in a data center, whatever it might be, right? Incident management, right? All those controls that we live and breathe as cybersecurity professionals should be implemented in some capacity, which will reduce the likelihood to an acceptable level in your organization.
All right, and you've said that you try to avoid changing 3-2 because it needs to be understood the same way by everybody in a large organization worldwide. Can I ask you maybe a different question? You've been doing this for a while. You've been using 3-2 for a while. Before you started the process, when you got into this business, what do you wish someone would have told you? Sort of what's the big piece of advice you can give to someone saying coming into this, here's what you need to watch out for?
Yeah, I think one of the first things that I would recommend organizations do is have a really good understanding of what controls your organization has in the OT environment, who's operating them, and how mature are they from an effectiveness standpoint. There's been too many cases where I've started off a workshop and started talking about controls, and then somebody pipes up and says, well, it's not working here because we haven't onboarded that system, or that host is not part of the domain, or this vendor hasn't given us the go ahead to maintain it ourselves. They're still maintaining it, et cetera, and you start going down a rabbit hole. And it's a huge deterrent, right, for moving forward in the cybersecurity risk assessment activity. So spend the time, front load a lot of this work, and do spot checks to ensure that whatever controls you have listed are operating effectively in your organization. That will make the whole workshop and this whole activity go much smoother.
So it sounds like in his example, Paul's describing an organization where security is sort of, the process has been started, there's stuff in place, but it's not actually done yet. Like the picture isn't complete. Is this something that we would expect commonly?
Unfortunately, I think the answer is yes. Industrial control systems are frequently really messy environments. There's an incredible number of vendors involved. There's a huge number of devices involved, and it's not, that there aren't tens of thousands of laptops on an IT network. It's just that these devices tend to be more different than the same. Out of my own experience, I remember, sitting in a planning process for deploying. I mean, Waterfall sells unidirectional gateways. We were replacing an IT/OT firewall with a unidirectional gateway. And one of the things you have to do is figure out exactly what's going through the firewall so that you can make sure you replicate all that stuff out to the IT network through the gateway. So we're going through reviewing the firewall rules, one rule after another. That system, yeah, we talked about it already. That's the PI system. Oh, okay. That rule, that's a system that we used to have 5 years ago and we don't use anymore. And, people are looking at each other in the room saying, well, are the servers still deployed? And they're going, well, I think they are. But, who's receiving that information on the IT network? Are the receivers still deployed? We might have thrown in erased them and thrown them in the garbage. And, they're trying to figure stuff out on the fly. And, the next rule comes and they say, what's this? I don't recognize this at all. No, that's a leftover from the Cisco firewall that we had in the previous firewall, not the current firewall. And it meant blah, blah, blah. And they try and figure out, is it still around? Move on to the next rule. That's a Barracuda rule. And we're, the question, I thought the previous firewall was a Cisco. No, that's the one from before the previous firewall. That was the Barracuda management system, I think. Well, can we get rid? So, like I said, this is more common than you might think. They can be noisy, messy environments. And I think Paul's point is, do your homework before you waste the time of 12 people sitting around the room trying to do a risk assessment while you figure out in real time, what still exists in your plant. All right. And you've talked about sort of the risk assessment team a few times. Who do you like to have on that team? How do you assemble that team?
Yeah, so you need to have the right people in the right room, and that's a very broad statement, but you need to understand and get views from the operators, from the maintenance teams, from the safety system engineers, right? Network engineers. So people need to be in the room that can talk about how the network is architected. You need cybersecurity professionals, you need risk professionals. You also need a finance view, right? What if a certain unit goes down? What's the financial implications, right, to our organization by not being able to produce or have product that is off spec, et cetera, et cetera. So it really depends on the activity, but you need to be able to have people that can talk to the people, asset, community, environment, and consequential business loss impacts in your organization.
And when you get this team together, I mean, we've talked about sort of the big lesson before you start. Once you get into the weeds, have you found some surprises down there? What should we be watching out for when we're deep into the process?
Yeah, so certain zones that kind of surprised us, right, were there were USB license dongles, right? Dongles and USB still exist, and if that license is if that USB device is stolen or misplaced, there's lots of work, right? You have to relicense, right, the whole DCS environment, possibly purchase new licenses, etc. So from a physical threat perspective, the USB license dongles were their own separate zone, and that was a bit of a surprise to us. And also handheld calibration units were a surprise to us too, because the operations stated that these calibration devices in the wrong hands could actually reprogram a field safety system, even if your PLC is locked, right, with the key position, etc. So it bypasses a lot of the traditional controls. So that was an interesting kind of zone that we assessed as well. The HVAC system is traditionally not part of your OT environment, but in certain refineries and chemical plants, the HVAC system is really critical from a people perspective because it keeps the building pressurized against explosions and toxic gases. So we've actually come across that a few times where the cybersecurity controls around the HVAC, the heating, ventilation, air conditioning systems is not well understood. And so we've kind of raised that as well. And then physical failures too, right? We've started looking at that too, because HP had a firmware bug after 40,000 hours on some of their SSDs. The hard drives failed, right, because the firmware was not being updated on SSDs, which is kind of unique, right? Not a lot of people think about that. So as you start doing these cybersecurity risk assessments, all these things, these interesting kind of scenarios start to percolate up.
Andrew, correct me if I'm wrong. It sounds like a lot of what Paul's talking about is operational and has maybe less to do with cyber specifically.
You're right to an extent. Cybersecurity, a lot of the consequences of cybersecurity threats are not, they're not all safety. Some of them are just the plant goes down. And so these risk assessments, in my recollection, in my understanding, they do tend to drift a little bit sometimes. Mostly they're focused on security. They're focused on deliberate attacks. But they're touching on, other cyber issues, operational issues that might take the plant down. And, people generally welcome becoming alerted to issues like that they might not have taken into account earlier. But another reason, in my estimation, why people sort of don't mind drifting across that line and then drifting back is insiders. I mean, Paul gave the example of the USB dongle. You might think, hey, if someone misplaces the license dongle and the whole control system stops working and the plant goes down, that's an operational issue. That's not really a cybersecurity issue, unless it's an insider who's deliberately misplaced the dongle to take the plant down. So, the operational space is where insider attacks start getting fuzzy. Is this an operational issue? Could it be a deliberate issue? And so, to me, it is relevant, and it's something that in my understanding of the space, it's a line people don't mind occasionally crossing. Okay, so those are sort of surprises on the nasty side. Have you run into any surprises on the good side in terms of controls or mitigations that you discovered that sort of were more effective than you expected?
Yeah, definitely. Yeah. So this is one of the reasons why I like doing these cybersecurity controls, because I'm always surprised and I always learn from assets on what approach and what controls they have implemented. So from a cybersecurity perspective, most of us gravitate towards buying new equipment or new licenses, etc. But sometimes the simple controls are the most effective. And I'll give you a few examples here. An asset was using a Windows XP machine, and they virtualized it, so that was great, right? A lot of assets, still Windows XP machines are still alive and well in many industrial control systems. But the cool control that they've actually implemented is they actually shut down this virtual machine that is an engineering workstation when not in use. And so engineering workstations traditionally, depending on your deployment, are not always used. Right. And this asset said, well, we're not using it, so we're actually going to remove it from our attack surface by shutting down the virtual machine. All right. And it's only brought up when engineering functions need to be used. And they put that under the permit to work process. And they also have a testing procedure to make sure that the VM does start up, which I thought really cool. Firewall rules. I've seen another asset actually implement timed firewall rules. So they have a machine on their network that does periodic scanning, and they didn't want that to be compromised by an adversary to launch a destructive scan of the OT network. So they actually implemented a 1-hour timed rule to allow the scan to initiate during the scheduled scan that occurs at that particular asset. So I thought that was kind of cool. And then decommissioning hosts, right? Consolidating, right? Hosts as well, virtualizing host, dealing with contracts, updating contract terms, right? All are kind of simple, implementing dip switches, additional training, all those kinds of things, right? Are controls that don't cost, but it don't cost anything and are very easy to implement and very effective from a cybersecurity standpoint.
And you've mentioned, safety a few times. Obviously, cyber vulnerabilities that can result in casualties, environmental damage are very serious. But you're dealing with sites that have done, HazOps and process hazard assessments in the past. How does cybersecurity fit with safety?
Yeah, it fits very well, and there's more importance on it, Andrew. I think in the coming years, we're going to see more synergies and more dovetailing of those disciplines. Traditionally, the functional safety teams are not cyber literate, right? Or that's not their subject matter expertise, right? It's more of a functional safety. But with architectures blending, there's numerous vendors out there that have integrated SIS and BPCS infrastructures, right? The risk is substantial. And what we've trying to do, this is kind of uncharted territory currently in the organization, but one of the things that you want to strive for in a mature cybersecurity risk assessment is understand if any of your HazOps situations or scenarios are 100% cyber vulnerable. And what I mean by that is you want the initiating event and all the controls that are implemented are cyber vulnerable or hackable, right? Ideally, you would not want that, right? Because you're putting a lot of reliance on your cybersecurity controls. And so ideally, you would like to have some kind of mechanical device to be able to protect you, right, from a particular scenario, right? Whether it's overpressurization, leaks, right, explosions, etc. So you'd want like a pressure sensing valve, maybe a relay or some kind of ruptured disk or a mechanical overspeed switch, etc. But a lot of the HazOps and the functional safety teams haven't really considered this and do put a lot of reliance on cybersecurity controls in their HazOps.
So you said that sometimes when you look at a safety scenario, you conclude that a cyber attack could, in the worst case, bring about that scenario, and there aren't physical mitigations in place. All of the mitigations in place are cyber. When you hit that, what do you do?
Yeah, this is an excellent question. The first thing is the hardest thing is finding those kinds of scenarios, right? This is very time intensive. You have to read the HazOps reports, which sometimes are in the hundreds of pages. And cybersecurity individuals are not functional safety experts as well. So this is where you need to, sit down with your functional safety people and really go through with a fine-tooth comb to kind of understand the certain scenarios. And once you have those threat lines, you can have more in-depth discussions on whether that is acceptable to the organization or not. There's no real easy answer to this where it's not an if or then statement, right? And so you have to have those discussions with the organization and understanding that we're putting a lot of emphasis on our cybersecurity controls to keep our asset in safe production and safe manufacturing scenarios. And maybe that will require you to go back and make a justification as part of your business case to improve or increase your cybersecurity funding. Maybe you would have to go back and look at your HazOps and for unacceptable kind of scenarios, maybe put in, right, a physical device next time you review the HazOps with the organization. But this is kind of uncharted territory, right? A lot of organizations are still, at the cusp of understanding this and looking at this and understanding kind of next steps on how they should be doing this.
So this has been great, and we've been talking for a while. I'm going to ask you in a moment to sum up, but before we get there, is there anything we've missed? What other sort of lessons would you like to impart from your long experience using the 62443 risk assessment methodology?
Yeah, so I think one of the things that was surprising to me when we started doing this is that there's actually some controls that our vendors were doing without our own knowledge, right? So yes, we have our own standard and we think we do a good job implementing it and operationalizing it, but we were surprised that some of our third-party contractors were actually doing cybersecurity risk and controls without our knowledge that we could actually take credit for. So one of our third-party contractors actually was upgrading their compressors without our knowledge. So they were periodically on an annual basis doing maintenance and updating the firmware on their devices, and which was a surprise to us. They were kind of doing it without our knowledge as part of their maintenance cycles, which we thought was definitely enterprise first and was very welcome. So my recommendation is also look outside, or don't have tunnel vision only internally within your own organization. Contact your third parties, and hopefully they have an interest in this and are willing to have those discussions and ask, are they doing firmware updates, right? Do they have any additional security features in their protocols that can be enabled, right? Et cetera, right? And you'd be surprised, right? Sometimes you will find a gem, and you will be surprised by their responses.
Well, Paul, this has been great. Thank you so much for joining us and sharing your insights. Before we let you go, can you sum up for us what are sort of the key takeaways here? What should we be thinking about when we're doing these risk assessments?
Yeah, so I think the theme that comes to mind is being realistic, Andrew, right? And I mean that in multiple ways. So first, right, I think we have to be realistic that we're early on in this process, right? The trajectory that we're on is going to require development of skills, development of process, right? We have to build that organizational and industry muscle, right, to be able to do these cybersecurity risk assessments. So that's point number one. Point number two is when you do these workshops, be realistic and have an operational mindset. Because when you're doing these risk assessments in the admin building or in head office somewhere in a conference room or on Microsoft Teams or Zoom, a lot of the things on paper might seem like they're a great idea at the time. Let's roll out a new industrial firewall or a data diode in the field or whatever it might be. But have you considered, is there enough space on the DIN rail? Is there enough power, right, to the cabinet? Who's going to do it? Who's going to pay for it? Who's going to support it, et cetera, et cetera. So you have to have an operational mindset and have those maintenance and the operations teams as part of your discussion. Yes, this is a good idea, but is it supportable, or is it going to die on the vine? All right. So have that at the back of your head. Don't start implementing or recommending things that are not feasible to do in the field. And then be realistic. Don't just talk about it. Don't be an analysis paralysis, right? It's not perfect, right? Learn by doing. Yes, the first one or the first iterations of your cybersecurity risk assessment are not going to be perfect, but at least you'll have, one under your belt or two or three under your belt. You'll have learnings, right? You can roll them into subsequent cybersecurity risk assessments. The only real way to learn is by doing. So encourage you to get involved and contribute as much as your schedules allow into your organizational cybersecurity risk assessments. And with that, thank you very much for the invite, Andrew. I really appreciate it. And I am on LinkedIn, and so I encourage anybody that has additional questions or comments, feel free to reach out to me and make a connection.
So that was your conversation, Andrew, with Paul Piotrowski. Do you have anything to take out our episode here?
Sure. I learned a lot in this episode. I've been involved in the risk management process for a long time, but not so much risk assessments. So specifically, I liked some of his detailed insights. I heard people talking about powering off engineering workstations or the engineering VMs, virtual machines back 5 years ago when the Triton attack took advantage of a safety programming workstation. But I haven't heard that piece of advice, so much ever since. And it seems like really good advice. More generally, Paul's main takeaways make perfect sense. Get started, get the right people in the room, be realistic about the process. Even if you can't fix everything that you see the first time, you can get the process started. You can start turning the wheel, getting experience and making things better as the years go by. And, when I was talking to Paul, I really did get the impression that he was open to engaging with the community. So, do reach out to him on LinkedIn, Paul Piotrowski, and keep the conversation going.
All right. Well, thank you to Paul for sitting down with you, Andrew. And as always, Andrew, thank you for speaking with me.
Thank you, Nate. It's always a pleasure.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.